Good afternoon, dear students. Now I want to discuss NEET 2025 question paper. First question, if the molar conductivity of a 0.05 molar solution of a monobasic weak acid is 97 centimeter square mole inverse, its extent of dissociation will be. Now, molar conductivity at infinity dilution for monobasic weak acid is equal to cation limiting molar conductivity plus anion limiting molar conductivity. So 349.6 plus 50.4. Then what is the value? 407 centimeter square mole inverse. Now degree of dissociation formula alpha equal to molar conductivity at a particular concentration by molar conductivity at infinity dilution. So that is equal to molar conductivity at a particular concentration 97 centimeter square mole inverse by molar conductivity at infinity dilution 407 centimeter square mole inverse. Then 0 you can cancel 9 by 40. Then 9 by 40 means what is the value? 0.225. This is the answer, 0.225. Then which option is right answer? Option 4 is right answer. Now moving to next question. A hypothetical diatomic molecule with bond order 0 is quite stable. This is the statement 1. Now statement 2. As bond order increases, the bond length increases. So statement 1, a hypothetical diatomic molecule with bond order 0 is quite stable. This is a false statement, wrong statement. So bond order, suppose bond order is equal to negative or 0, then that molecule is unstable. That molecule is unstable. So statement 1 is wrong. Here quite stable given, na? So unstable. As bond order increases, bond length increases. So now bond order that is inversely proportional to bond length. So statement 2 also wrong. Here both statements are wrong. Both statements are false. So option 3 is right answer. Now moving to next question. The ratio of the wavelengths of light absorbed by a hydrogen atom when it undergoes n equal to 2 to n equal to 3 and n equal to 4 to n equal to 6 transition respectively is. So now here we can use the Rydberg equation. What is the formula? 1 by lambda equal to r into z square into 1 by n1 square minus 1 by n2 square. So this is the formula. Now here n equal to 2 to 3 transition, 2 to 3 transition. Then 1 by lambda 2 to 3, that is equal to r into, for hydrogen atom, 1 square into 1 by 2 square 4, 1 by 3 square 9. Then 1 by lambda 2 to 3, that is equal to r into here 5 by 36. Then lambda 2 to 3, that is equal to 36 by 5r. 36 by 5r. Now transition 4 to 6. Transition 4 to 6. Now 1 by lambda 4 to 6, that is equal to r into 1 square into 1 by 16, 1 by 36. Then 1 by lambda 4 to 6, that is equal to r into 36 minus 16, 20 by 16 into 36. So now here 4 5's, 4 4's cancel. So now lambda 4 to 6, that is equal to 4 into 36 by 5R. Now, here ratio asking. So, lambda 2 to 3 by lambda 4 to 6. So, that is equal to 36 by 5R whole by 4 into 36 by 5R. Now, here 36 cancel, 5R cancel. Then, what is the answer? 1 by 4. This is the right answer, 1 by 4. So, which option is right? Option 1 is right. Option 1 is right. So, moving to next question. The correct order of the wavelength of light absorbed by the following complexes is CONH3 6 times whole 3 plus, COCN 6 times 3 minus, COH2O 4 times 2 plus, TH2O 6 times 3 plus. Choose the correct answer from the options given below. Here wavelength of light absorbed by following complexes is. So which complex is, in which complex weak field ligand is there? Then in which complex electrons will not be paired? It follows Hund's rule. So in which complex weak field ligand is there? In that complex electrons will not be paired. Then there is chance to more number of electrons are there. More number of unpaired electrons, then it can absorb more wavelength of light absorption. So that here ligand field strength order I provided from NCERT textbook. Here option A ammonia, option B cyanide, option C and D. So compound C and D water molecules provided. So compound A, B, C, D, ammonia, cyanide, water ligands provided. So now ligand field strength order here observe ammonia, here cyanide very strong field ligand, after that ammonia, and after that water. So that water is weak field ligand. So where water has weak field ligand, there more number of unpaired electrons possible. But coming to compound C, compound D, compound C water molecule, compound D also water molecule as a ligand. So compound C water molecule is there now. This is a tetrahedral complex. It is a tetrahedral complex. Whereas coming to D, it is octahedral complex. Octahedral complex. So now, you know, as compared to tetrahedral complex, octahedral complex is more stable. So that here may be electrons, less number of electrons available. So that here tetrahedral complex somewhat less stable as compared to octahedral complex. That's why COH2O 4 times 2 plus more number of unpaired electrons available, we can assume like. So compound C absorbs more wavelength of light. So in which option compound C is in greater? Option 2, option 3. In both options compound C greater. After that compound D. After that compound D. So then which option is right answer? C greater than D means option 3 right answer. Option 3 right answer. After that ammonia. After that cyanide very strong field ligand. That's why in which complex less number of unpaired electrons may be possible. So very low wavelength of light absorption takes place. So this is the right answer. Option 3 is right answer. And I provided complexes and their wavelengths from NCERT textbook. It is very useful for you. And here you can observe what complexes are provided, their wavelengths provided here, and TH2O 6 times 3 plus, TH2O 6 times 3 plus, and its wavelength 498, and after that COH2O 4 times 2 plus, that complex is not there, and after that COCN 6 times 3 minus, and 310, COCN 6 times 3 minus 310, and COH2O 6 times CO NH3 6 times 3 plus 475. Then TiH2O 6 times 3 plus, that is greater than, and CO NH3 6 times 3 plus, that is greater than CO CN 6 times 3 minus. This data also can help us. Okay, so here option 3 is right answer. Now moving to next question. If the rate constant of a reaction is 0.03 second inverse, how much time does it take for 7.2 molar concentration of the reactant to get reduced to 0.9 molar? Here rate constant value given, what is the value? 0.03 second inverse. Now rate constant units for K, mole power 1 minus n, liter power n minus 1 second inverse. If order is 1, then K equal to mole power 1 minus 1, mole power 0 1, liter power 1 minus 1, liter power 0 1, so second inverse. So rate constant value second inverse means it is first order kinetics. Okay, from the units of rate constant we can decide its order. So its order is 1. Now we can calculate here time. Now first order rate constant, its formula K equal to 2.303 by T log A naught by A naught minus X. So now time here K value, rate constant and off-life formula also we can use. Here off-life here needed, no, off-life not given, so directly we can calculate here, off-life not needed. T equal to 2.303 by K value, rate constant value 0.03 log, and initial concentration A naught 7.2 and A naught minus X, so total value it gets reduced to 0.9, then 2.303 by 0.03, this is log 8. Now 2.303 by 0.03, this is log 2 cube, 3 log 2. Then here 2.303 by 0.03 into 3 and log 2 value 0.3010. Now here we can write 230.3 by 3 into 3 into 0.3010. So 3 cancel. If we simplify, then we will get answer 69.3 second. So which option right answer here? Option 2 is right answer. Option 2 is right answer. Now moving to next question. Match list 1 with list 2. List 1 mixer, list 2 method of separation provided. Chloroform and aniline. This mixture can be separated by using simple distillation, because chloroform, aniline, their boiling points differ greatly in magnitude. So that's why this mixture can be separated by using simple distillation. Crude oil in petroleum industry, so this is fractional distillation. And glycerol from spent lye, here distillation under reduced pressure we can use. This is also named as vacuum distillation. What is this? Vacuum distillation. And aniline water, separation of aniline from aniline water mixture, from that we can use steam distillation. So then which option is right answer? Option 2 is right answer. Option 2 is right answer. A is matched with 4 and B is matched with 3 and C is matched with 1 and D is matched with 2. So option 2 is right answer. Now moving to next question. The major product of the following reaction is So cyanide provided and ketone functional group also there, and methyl magnesium bromide excess, and followed by acidic hydrolysis. So now double bond O methylene methylene and double bond O CH3. Wait, cyanide no? C triple bond N. C triple bond N. Now excess methyl magnesium bromide. Now CH3 MgBr. In Grignard reagent, alkyl part having negative charge and rest of the part positive charge. CH3 negative, rest of the part positive. It undergo nucleophilic addition. It undergo nucleophilic addition. O minus MgBr plus. So like nucleophilic addition takes place. Now followed by hydrolysis. HOH. Here we can break bond, oxygen, hydrogen, and we can break bond like HOH. We can hydrolysis like this is the trick. So then ketone converted into tertiary alcohol and this cyanide converted into ketone. So then this is the right answer. So which option is right answer? Option 3 is right answer. Option 3 is right answer. Option 3. So cyanide with methyl magnesium bromide converted into ketone, and already ketone is there, it will be converted into tertiary alcohol. So which option is right answer? Option 3 is right answer. Option 3 is right answer. Now moving to next question. Which one of the following compounds can exist as cis-trans isomerism? 1,2-dimethyl cyclohexane, 1,2-dimethyl cyclohexane, 1,2-dimethyl cyclohexane. This is the compound. It can exhibit geometrical isomerism. So disubstituted cycloalkanes exhibit geometrical isomerism, cis-trans. So two methyl groups we can connect with solid lines, and one methyl solid to one methyl dot. So same plane, two methyl groups are in same plane, cis opposite plane trans. So first option, it can exhibit geometrical isomerism. Now moving to second option, pent-1ene. Here on same double bonded carbon atom, two identical hydrogen atoms are there. Two identical hydrogen atoms are there. So it could not exhibit geometrical isomerism. It could not exhibit geometrical isomerism. Now moving to third one, 2-methyl-hex-2ene. Here also on same double bonded carbon atom, two identical methyl groups are there. Two identical methyl groups are there. It could not exhibit geometrical isomerism. Now moving to fourth compound, 1,1-dimethyl cyclopropane. So disubstituted cycloalkanes can exhibit geometrical isomerism, but two alkyl groups can substitute on adjacent carbon atoms 1-2 positions, 1/3 positions like. But here two alkyl groups attached to same carbon atom, two methyl groups substituted same carbon atom. That's why it could not exhibit geometrical isomerism. So that which option is right answer? Option 1 is right answer. Which is right answer? Option 1 is right answer. Now moving to next question. Among the following, choose the ones with equal number of atoms. Means total number of atoms, atomicity formula. Total number of atoms is equal to mole into Avogadro number into atomicity. Now first one, here what is the question? Choose the ones with equal number of atoms. Now total number of atoms is equal to mole into Avogadro number into atomicity. First one, 212 grams of sodium carbonate. Here mole 212 by 212 by its gram molecular weight 106 into Avogadro number into, in sodium carbonate how many atoms are there? 3 atoms. So then 12 Na. Now moving to compound B, 248 grams of Na2O. Na2O its gram molecular weight 62. So 248 by 62 into Avogadro number into how many atoms in Na2O? 3 atoms. So 12 Na. Now moving to compound C, 240 grams by sodium hydroxide gram molecular weight 40 into Avogadro number into 3 atoms. Then 18 Na. Now coming to D, 12 grams of H2. H2 molecule molar mass 2 grams, 12 by 2 into Avogadro number into 2. So 12 Na. Then moving to E, 220 grams of CO2. CO2 weight 220 by its molar mass 44 into Avogadro number into, in carbon dioxide how many atoms are there? 3 atoms. So then we will get 15 Na. Now which compounds having equal number of atoms? Here A, B and D. A, B, D having equal number of atoms. So which option is right answer? Option 3 is right answer. Option 3 is right answer. A, B, D. Now moving to next question. Among the given compounds 1, 2, 3, the correct order of bond dissociation energy of CH bond marked with star is. Here 3 compounds provided: benzene, hydrogen, benzene, and phenylacetylene, next cyclopropene. Here the bond is labeled with star. So now bond dissociation energy we need to determine, CH bond dissociation energy. You know, benzene carbon double bonded carbon sp2 hybridization, and phenylacetylene triple bonded carbon sp, and cyclopropene single bonded carbon tetrahedron carbon atoms sp3. Now in sp2 hybridization percentage S character 33%, in sp hybridization percentage S character 50%, in sp3 percentage S character 25%. Now percentage S character increases, then stronger the CH bond. If higher the percentage S character, then stronger the CH bond. Then it requires more bond dissociation energy. So that here, where higher the percentage S character, there stronger CH bond. That carbon connected hydrogen bond is strong. Then it requires more dissociation energy. So that triple bonded adjacent carbon greater than double bond adjacent carbon, then single bonded adjacent carbon. So that 2 is here bond dissociation energy order, bond dissociation energy order 2 is greater than 1 is greater than 3. Then which option is right answer? Option 2 is right answer. Option 2 is right answer. Now moving to next question. If the standard heat of formation in kilocalorie of barium 2 plus ion is, standard heat of formation of sulfate ion aqueous minus 216 kilocalorie per mole, standard heat of crystallization of barium sulfate solid minus 4.5 kilocalorie per mole, standard heat of formation of barium sulfate minus 349 kilocalorie per mole. Here first one, standard heat of formation of sulfate. What is the definition of standard heat of formation? 1 mole compound obtained from the standard atomic or elemental forms. If one mole compound obtained from its standard stable atomic or elemental form, then that reaction is known as standard heat of formation of a substance or standard heat of formation of a reaction. So now here sulfur atomic form means standard form, solid. Oxygen in gas standard form plus 2 electron giving rise to sulfate, and its value minus 216 kilocalorie per mole provided. Next, coming to standard heat of crystallization, and when two oppositely charged gaseous ions come close together to form 1 mole crystalline compound, barium 2 plus gas plus sulfate ion gas giving rise to barium sulfate solid. Its crystallization value minus 4.5 kilocalorie per mole given. Next one, standard heat of formation of barium sulfate. Again, barium sulfate solid should be formed from its standard stable atomic or elemental forms. Then barium solid plus sulfur solid plus 2O2 gas giving rise to barium sulfate solid. Its value minus 349 kilocalorie per mole given. But here we need to calculate this part. What is that? The standard heat of formation in kilocalorie per mole of barium 2 plus. This one we need to calculate. So barium 2 plus standard heat of formation means we need to form barium 2 plus from its standard state, means barium solid. This reaction indicates standard heat of formation of barium 2 plus. Its standard enthalpy formation we need to calculate. Then how can we get this one? If you subtract 1 and 2 from 3, then we will get this standard heat of formation of barium 2 plus. So from third equation you can subtract first and second. So third equation we wrote same, first equation we reversed and noted here, and second equation also we reversed and noted here. Then all three reactions if you added, then here all terms cancelled, and finally we got barium solid giving rise to barium 2 plus gas plus 2 electrons. Then standard heat of formation of barium 2 plus ion, that is equal to minus 349 plus 216 plus 4.5. Then finally we got minus 128.5 kilocalorie per mole. So which one is right answer? Minus 128.5 means option 2 is right answer. Option 2 is right answer. So among the all questions, 45 questions from NEET 2025, this is somewhat little bit difficult. Okay, so somewhat tricky question. Now moving to next question. Consider the following compounds: KO2 means potassium superoxide, H2O2 hydrogen peroxide, and sulfuric acid. So underlined atom, their oxidation states we need to calculate. First one, potassium, how it is breaking K plus O2 minus. So potassium oxidation state, so that is +1. Alkali metals, their oxidation state +1 always, because in their valence shell only one electron is there. They readily lose that one electron only, +1. Now hydrogen peroxide, how can we write? H single bond O, H. This is hydrogen peroxide. Here oxygen -1, peroxide bond -1. Then oxygen oxidation state -1, peroxy bond, peroxide. So hydrogen here +1, but oxygen -1, oxygen oxidation state -1. Now coming to sulfuric acid, sulfur X, and 2 into hydrogen +1 plus 4 into oxygen -2, that is equal to 0. Then here oxidation state of sulfur +6. So +1, -1, +6. Then which option is right answer? Option 2 is right answer. Option 2 is right answer. Now moving to next question. Out of the following complex compounds, which of the compound will be having the minimum conductance in solution. So in aqueous solution, which is providing less number of ions, that will be having minimum conductance in solution. So first one we can ionize it as CO NH3 5 times Cl whole plus Cl minus. So N equal to 2 ions. Second one, no counter ionic part, no counter ionic part. So that's why it is a neutral complex. So 0 ions. Third one also no counter ionic part. It is also having 0 ions. We can be considered 0 ions. Now coming to fourth one, how it is ionized? CO NH3 6 times whole 3 plus 3 Cl minus 4 ions. So then here compound 2, compound 3 both having 0 ions. Then both having minimum conductance in solution. So here option 2 right and option 3 also right. Option 2 right and option 3 also right. Both options are right. Now moving to next question. Which of the following reactions does not give benzene as product? Does not give benzene as product. First one, when benzene diazonium chloride treated with warm water, then phenol is obtained. Warm water, phenol plus here N2 plus HCl, because water we can ionize like H plus OH minus, that OH substituted here in the place of azo group N2 plus HCl. So phenol obtained. But here does not give benzene as a product means yes, one is right only. And sodium benzene treated with soda lime. Soda lime means NaOH plus COO. So here calcium oxide catalyst can act as catalyst and sodium hydroxide can act as co-reactant. Then benzene obtained plus sodium carbonate eliminated. So benzene is obtained. Next one, N-hexane undergoes aromatization reaction. You know aromatization reagents, molybdenum oxide and vanadium pentoxide and Cr2O3. Any one of them you can use. So then here benzene obtained. This is also type of oxidation reaction. Here C6H14 N-hexane molecular formula and benzene C6H6. So how many hydrogens removed? 8 hydrogens as 4 H2 molecules removed. So this is oxidation. Next, acetylene. When 3 mole acetylene undergo polymerization reaction, the presence of red hot iron tube at 873 Kelvin, then we got benzene. So that here option 2, option 3, option 4 we got benzene, but in option 1 phenol. So here does not give benzene as a product means option 1 is right answer. Option 1 is right answer. Now moving to next question. Which of the following are paramagnetic? Which of the following are paramagnetic? NiCl4 2 minus, NiCO 4 times, NiCN 4 times 2 minus, NiH2O 6 times whole 2 plus, NiPPH3 4 times. Choose the correct answer from the options given below. So first NiCl4 2 minus. Here nickel is weak field ligand and chloride ion is weak field ligand. So we can calculate nickel oxidation state. Here we got nickel oxidation state plus 2. What is the nickel outermost electron configuration? 3d8 4s2. So in which complex nickel plus 2 oxidation state? No? So 2 electrons left from s orbital. So 3d8 4s0 4p0. And one more thing, chlorine is a weak field ligand. Electrons will not be paired. It follows Hund's rule. So then how many electrons are there? 2 unpaired electrons are there. So it is paramagnetic in nature. Paramagnetic in nature. Now moving to next one. NiCO 4 times. Carbon monoxide is a very strong field ligand. And in which complex nickel oxidation state 0, because carbon monoxide is neutral ligand. And here electrons neither lose nor gain. So 4s2 3d8 now all electrons paired in 3d subcell. So 4s is vacant, 4p is vacant. So around the nickel 4 carbon monoxide ligands are there. 4 carbon monoxide ligands, they can donate their lone pairs to 4 vacant orbitals. So sp3 hybridization. NaCl for 2 minus also sp3 hybridization. But here no unpaired electrons. Here no unpaired electrons. N value 0. So no unpaired electrons. So it is diamagnetic. Now moving to compound C. NaCN 4 times 2 minus, in which nickel oxidation state +2 and cyanide is a very strong field ligand. Then here nickel +2 state now 2 electrons left from s orbital, so 3d8. So in 3d subcell all electrons are paired opposite to Hund's rule, so 8 electrons. So one vacant d orbital is there. Then 4 cyanide ligands, they can donate their lone pairs to one 3d orbital and one 4s orbital and to 4p orbital. So dsp2 hybridization is square planar complex. So you know above two complexes are tetrahedral complexes, but NaCN 4 times 2 minus is a square planar complex. Here also no unpaired electrons. Here also no unpaired electrons. It is also diamagnetic complex. Now coming to NiH2O 6 times 2 plus. So it is 6 ligands are there around the nickel. It is octahedral complex. Octahedral. Of course, water is weak field ligand. Water is weak field ligand. So in which complex nickel +2 state? So now 3d8. 3d8. So 2 electrons left from s orbital na 3d8. And water weak field ligand. Electrons will not be paired. So 2 unpaired electrons are there. Then here 6 water molecules, they can donate their lone pairs to 6 vacant orbitals. So it is sp3 due to hybridization. sp3 due to hybridization. So 2 unpaired electrons are there. That's why it is paramagnetic complex. Now coming to last compound, NiPPH3 4 times triphenyl phosphine is ligand. Here nickel, in which complex nickel 0 oxidation state, because triphenyl phosphine is a neutral ligand. So neither lose nor gain electrons. So nickel, in which complex nickel oxidation state 0. So that's why here s electrons and d electrons all are paired together in 3d subcell. So no unpaired electrons, 0 unpaired electrons. It is also sp3 hybridization. So due to presence of due to absence of unpaired electrons, so it is a diamagnetic. So which complexes are paramagnetic in nature? Here compound A and compound D. These are paramagnetic in nature. Compound A and compound D. Remaining all are diamagnetic in nature. Compound A and D. So option 4 is right answer. Compound A and compound D. So I hope everyone understood all these solutions. So 15 questions we discussed now. So for the rest of the questions I will make another video. So thank you so much.